Very cool. We have a couple of attendees. I see Mr. Boucher. Hey, Mike, how you doing? Hadn't talked to you in a long time. I'll warn you, I have a cough that one of my many children brought home and gave to me, as they are often well versed in giving. But I'm really excited about this conversation. So instead of doing a sort of traditional, let me show you a slide deck and let's talk about, the 5 points that I have in my head, I wanted to bring together a list of people that I respect and that we've had a lot of really fun conversations internally about AI and its impacts on software engineering. So, for those of you who don't know who we are Seven Factor. We're a software engineering firm. We've been in business 10 years this year. It's crazy to think that I started this thing 10 years ago. And I like to say I collect smart people, and I've done that. I have three incredibly smart engineers on the phone with me. Real quick, let's go around the horn. Let's start with Jeremy Wood and then go to Scott and then Jeremy Berven. Just quick 1 minute intro. Go ahead.
Yeah, Jeremy Wood. I'm principal engineer here at Seven Factor. Um, I've been uh, leading our AI council for a while now and have kind of been um, in the mix with AI since college. So,
Yeah, me too, for sure. Scott Fisher.
Hi. Scott Pfister, I'm a principal engineer as well. I was an engineering manager until recently, so I've kind of shifted back into being hands-on coding. But I've been doing this a long time. I think I started in '95, and so I've started from C and C++ to early Java, Ruby,
Mhm.
Elixir, and I was kind of right there in the middle of it when all of the exciting things happened when the internet kind of became a thing with the web,
Mhm.
and the changes that I've seen going on with AI, I think are really, really exciting because I don't think anything's felt the same ever since. And
Yeah.
this feels like Web 2.0 or Web 1.0, times
Mhm.
10. It's amazing.
I actually agree with you. I grew up without the internet and got the internet, so quite didn't get it started probably as early as you did, but we have some similar experiences.
Oh yeah.
Berv,
Yeah, I'm Jeremy Berven, go by Berv for obvious reasons.
three
I have
Jeremys,
been
right?
I've been a software engineer for going on 13 years now. Started in fintech and then transitioned into consulting here at Seven Factors. So I've kind of gone through a couple of learning curves already in the industry, just having been a product person and then now cloud and consulting. So another learning curve is on its way with this stuff we're going to talk about today.
Yeah, for sure. All right, so we wanted to first talk about a few agentic and the ideas of what agents mean for software engineering. And I kind of want to set the table here, and then we can kind of jump in together. And if you have any questions on the phone, feel free to just shoot those in the chat. Lou will flag us, and we'll go ahead and just talk and be a part of the discussion here. Again, we're not going to run this the way you run a typical webinar. I wanted to get together, just discuss some of the things that we've discussed internally about the challenges and issues that we find with AI. And obviously, there are a few big issues with respect to using AI in production. All of our clients are using it at this point to certain degrees. Some clients more successfully than others. It is a excellent tool, and my general opinion, and I'll sort of set the table, and then we can go continue from there. My general thought process is, as Scott said, this is another revolution in how we deliver code. If anyone remembers IntelliSense, back when I was working at Microsoft, I got my first taste of code generation. My master's degree is in programming language design and static analysis, so I spent a lot of my career when I was at Georgia Tech doing research in various things like dead code elimination, how compilers optimize and operate in the JVM, hotspot profiling, stuff like that. So I've been using and viewing code generation for a very, very long time. And it wasn't until probably, I'm guessing, last month, maybe earlier than that. The last time I used Agentic to do anything was on vacation in July. I took my family. We went on a quick little vacation, and I was bored at the condo and spun up Claude. I forget which version it was to try and develop an API quickly, and it absolutely did a very bad job. Like, it produced something that kind of worked, but it didn't really do much in the way of producing what I would consider production code. Fast forward to 2 weeks ago, when I started playing with it again, I was able to spin up an entire working API suite with 60% test coverage in less than 30 minutes. Again, the challenge is I don't know what this code does because I've not read it. I just clicked a button and I got this giant PR. that I had to go and read. So I think there are a lot of inherent questions in this. So I think we as a company, and I think in general, we have to admit to ourselves that it's a very important tool. It's the laser chainsaw. We need to learn how to use this thing. But my question to us in the panel and the group is, how do we do so responsibly? And how do we look to the future of when we're training folks up and getting the next set of engineers coming in out of school? What is that going to look like? What is that workforce that's more AI native going to look like? We have some folks doing MQPs for us from Worcester Polytechnic, and I was talking to Paul about this, one of our engineering directors, and he's like, yeah, they'll shoot me a PR, and it's just obviously a giant blob of AI generated code, and I have no clue what it's doing. So there's this big question of where do we spend our effort as an industry? So I want to put that question in the panel first. Where do you think we should spend our effort and our time as an industry with these tools? Because they obviously have the ups and downs, but what do you think? Where do you think we should spend our time in an effort in continuing to grow our workforce around using these tools?
Do you want to pass that to
let's
anyone in particular?
start with Jeremy Wood. Let's start with you.
All right.
Yeah, sorry.
Sure.
With you, and then we'll go
So I think that with the state of the tooling right now, you can produce some pretty amazing stuff quickly. I don't know for sure that's like gonna mean that we produce software more quickly. It just means that we can write code more quickly. As someone said, like, code is now cheap, but software is still expensive. I don't think that's changing because of this. I think the really, like, where I'm seeing this is impacting is especially depends on kind of experience. So the people that are more experienced are gonna be able to use these tools to a greater effect, I believe. And then the people who are less experienced will get less out of them. And my concern there is that unless we can guide them correctly, it's going to be very difficult to train up new engineers to be experienced enough to get that value that the experienced engineers can get, because they're being pushed to use these tools and think they have to and all this. And so it's really been challenging to come up with, like, how do we deal with that problem? How do we deal with the talent pipeline in this new world?
And I think there are a couple of big issues in that. One is that when I was writing code, when I was a Journey programmer at Danger and other places, I was handed a giant code base that I'd never seen before. And my goal was to add a new feature to this giant code base, a couple of million lines of Java or Perl or whatever it was. And where did I start? Well, the first place I started was reading the existing code and trying to understand and parse it. And when we as engineers talk about being a craftsman, a craftsperson, one of the big underscores of that is that the code I write is readable by another human being, right? And that I would put my name on that code. And I would say, if anybody read that is me. That's Jeremy. And it's funny that GitHub did a study a long time ago about they could run hashes across different people's code and commits and actually identify the developer based on the code that they wrote by simply hashing it. You could get a pretty close match to know that this code was produced by Jeremy Berven and this code was produced by Scott Pfister and this was produced by Jeremy Wood. Every developer has a style and a way of writing and doing things that is unique to them. So fast forward to this world now where agents produce everything. And we're just clicking buttons and we're getting out of it what I put into it. Prompt engineering is also obviously one of the most important things. If you don't tell the agent, you don't know how to tell the thing what to do properly, you're going to get complete garbage or stuff that doesn't work out of it, right? But to your point, Jeremy, I find the difficulty in these future folks coming out of school, or who, the generation of programmers we have right now that have just started their jobs, is how do you teach them how to build software? We're no longer teaching them how to write code, right? Now we're teaching them how to design and build systems and build software from the ground up with a tool that will dump tons and tons of working code into a repository. What do you guys think about that? So let's pick someone else. What about you, Berv? What are your thoughts on this?
Yeah, so something that I have found has benefited me is, instead of the idea that I can just go to an agent and say, I need an app to do blah, right? And just sit there and let it crank out an entire API that I now have to go parse through, read, understand, find out what edge cases it missed and all that is I just have been integrating it into my existing process, which is plan ahead, right? Figure out what I want to do, and then let the AI agents do the steps that I had already planned on doing as individual steps so that when I go and inspect, okay, did it do this thing that I meant for it to do? It's a small chunk of that work, and I can massage it, fix it, refactor it to a human readable state. But again, that's coming from someone with experience in building things that are human readable and supportable and maintainable.
Right.
We need to try to educate these newer developers in what that means still, so that they're not just approving things and pushing things through that are not to that same standard.
So the counter argument that I hear from that though on the internet is, and Scott, feel free to chime in at any time. The counter argument I hear is that, well, you will never have to read code again. You'll just plug into a suite of agents. This is my description, vibe code style. We all know vibe code's a meme. Let me tell everybody on the phone, vibe coding's a meme. It doesn't work. Not right now. I don't think it ever will, but I could be wrong. I'll happily be wrong. But if the machine produces working output that does what it's supposed to do, why should I care about how to read it? I think that's an important question for us to attack.
Personally, I think it's a really, really difficult time for us to actually answer that question because there's the whole question about what are we going to do now? What are we going to do tomorrow when I show up to work and I need to, get a ticket implemented? And I've got an AI tool that can help me, but it can also hurt me. But I'll use your example, Jada, of what you saw changing just in a few months, and one particular example, and how much it's changed. And so, while I'm not wanting to plan and predict exactly what's going to happen in the future, I do want to embrace the idea that there's going to be a lot of things that are going to change really quickly. I saw some predictions from somebody, a guy named Simon Willison, who writes a lot on AI. He's got a great blog, and he had made some predictions for the next like 1 and 3, 5 years out. And one of them for this year was that it'll be impossible to deny that AIs write good code. It'll be undeniable. And I think we're seeing that. We're seeing the evolution of the code that they can write. And then as we start evolving into things like looking at orchestration and multiple agents, you can have a focused agent. I mean, who wouldn't have wanted, 5 years ago, if we're writing some kind of a web app, to have a security expert to review our code and to look for the gaps and the holes that we put in there that somebody could have used whatever to break into our system. Well, now we can have a little AI tool that does exactly that, focuses 100% on security, looking for those things based on all the examples it can find on the internet. Is it mean it's going to be perfect? No, but is it ever perfect?
Yeah, I mean, you just said the magic word on the internet, right? Because everybody
Yeah.
on the internet has an opinion. It's like the XKCD. Hold on a second, someone on the internet is wrong. And it's funny. Like I think I saw that Stack Overflow's user base has crashed because nobody even goes there anymore. Everybody just simply asks their AI tools. I mean, I think it really breaks down to something that Jeremy Wood and I talked about in our previous conversation, and that is, the trustability of these models. Are they trustable, right? Are they something that we can guarantee with some level of hopefully legal contract in place for these big companies that we work with, that if something goes sideways, right, there's some form of culpability in that the model was trained the way it should have been, right? And I think that's an important thing, but I mean, that's a totally different question. To your point, when I was talking to Paul earlier too, I mentioned to him, this is a fun question to think about. Has anyone ever done a hex edit on a binary? Have you guys ever done that before? I did this when I was like hacking games back in my early days, like of Windows, ME. Yes, that was a thing. Where I would download a hex editor and I would like hex edit my save files for Diablo 2 to fiddle around and screw with stuff. And my question to Paul when we were talking about this is that, okay, let's, in the context of readability, have you ever opened up hex and been like, man, this hex could be way more readable, right? I think they should have ordered these bits different, which I mean, obviously it's going to break it if you change the bit order. But all I'm saying is that if you change the hex file, right? Have you ever even thought of that? And again, going back to my background in compilers and LLVM and stuff I did in school, it's like I didn't care about what the assembly looked like. Did I get the same assembly every single time? No, because some of these algorithms are slightly non-deterministic in how it manages pipeline and how it manages code elimination. So you're not getting the exact same thing every single time. Mostly you are, to some degree, provably, you are getting a working piece of code. But on one architecture, it's totally different than it is on another architecture. Do you care? Do you care what assembly looks like on an ARM versus what assembly looks like on an x86 processor? No, nobody gives a crap. Are we at that point? I don't know. I don't think so, right? I'm playing devil's advocate a little bit. My personal opinion is that readability still matters, just for those of you on the phone that are like, this guy's crazy. I still think readability matters. I think it's something we need to think about and talk about together. But frankly, I think that's where my head started to go, right? As I'm exploring this space, it's like, what if you get to the point to where you don't even like the GPUs are so fast that you just click a button and regenerate the entire code base, and it's basically a binary, right? It's like a .exe that you just run out as a container in your service somewhere.
Yeah, but the fact that you had to do that at all in the first place meant that your original had issues, and now the new one will have issues that could be the same or
Exactly.
different,
Right.
right? And
Could be
so
the same
you're
or
just going
different.
to have a frustrated user base that is like,
Right.
you're just producing stuff. Does it matter that it doesn't work to you at all?
Right.
I think it
Um,
comes down a lot to what you're trying to build, right?
Mhm.
Because we talk about it in our world a lot. We talk about specifications. And in some industries, specifications are essential. When you're building medical devices, specifications
Mhm.
are critical. When you're building the space shuttle or
Yeah.
whatever the SpaceX's new launch is going to be, it's essential. When you're building a web app for somebody to do, solicit web leads from the internet, it's not nearly as much so. And so, what we can get out of simple short prompts versus how much we have to worry about the possible defects or, flakiness in that application and how we fix it is going to vary a lot. And I think that's where a lot of the expertise, as we grow into
Yeah.
using these tools more and more, we're going to understand how to protect ourselves from certain things as well as how to learn when to let go.
Right. And I mean, so recently I was showing our marketing team my silly microgreens API, and I actually live coded a feature with them on the phone. And the meeting was 45 minutes long. And I asked Claude to produce a behind a feature flag, which I wouldn't put this behind a feature flag, but I did it just to see if it could figure it out. Put behind a feature flag the ability to CRUD on user profiles and make sure that you only do soft deletes, because I don't want to actually delete a user profile. You just want to disable it, right? And in about 7 minutes, it produced 126 unit tests, and it produced an completely working suite of end-to-end tests, and it also produced the code that would do those features. And in addition to that, in my prompt, I said, make sure that this is protected from IDOR attacks, indirect object reference attacks, which is a common thing that most developers don't think about. Like you and I don't know, I didn't even know what an IDOR was until I got into enterprise architecture, and I'm talking to billion-dollar companies getting SEC filings, and they're like, hey, this is a pen test thing. This is a problem. And I look at the code and I'm like, yeah, this was old PHP. So it was complete and absolute garbage. Berv knows what I'm talking about. But we saw that we saw that it did it quickly, it did it correctly, and it did produce code that was in fact protected from IDORs. But I had to tell it to do that. And to your point, you said earlier on building agents with specific things. Security is a place where I get twitchy, right? Having worked in very secure environments, it's one of those things that I feel like we have to spend extra time ensuring. And Brent, I see your question. We'll answer that in a minute. It's a great question, by the way. We talked about this a little bit internally, is how do we do this? But security is one of those places where I don't know that a good CISO would ever trust AI completely. You're still going to have your pen testing. You're still going to have your static analysis. You're still going to have your Veracode. If anything, properly trained AI should become a better pen tester than perhaps even a human could. Again, I don't know for sure. Don't throw rocks at me. I'm not a pen tester. But just based on the what I'm seeing, it's very important for developers to not just know about how to write code now. It's no longer writing the colored words on the screen. The skill set that you're training is critically thinking about a problem and applying the right buzzwords and jargon to get the machine to produce what it is that the output that you're looking for, be that a secure API, et cetera. What do you guys think about that?
Well, so it's interesting, something I've brought up a couple times about using AI in this way. It's like where you're reviewing all of the code it generated, is that as someone really experienced, you're gonna look through this code and you're gonna find problems with it and make the corrections and so on. But you're also gonna miss problems because
Mm,
your brain isn't working in like a critical thinking mode as you're
mm-hmm,
reviewing this code. Just,
mm,
it's like when you're actually typing the code, it's like it feels like, at least for me, I feel this when I'm using AI versus not. It's like my brain is not engaged in the same way. And so what ends up happening is like it'll create something that looks really reasonable and I'll review it and I'm like, yeah, this looks right. And then find that wait a minute, there's a bug in this, and it's a bug that's really obvious. And
Hmm.
had I have written that out myself, this is probably something I would have not. It's like I would have caught it as I was writing it.
Yeah.
And
And so one thing on that, sorry, Jeremy. So back in the day, in my master's degree, I wrote a paper. I was a part of a paper. I implemented this paper, and we wrote a follow-on that talks about how branch coverage doesn't, in fact, solve the problem that you have a bug. And I can link to people to the paper if you want to look at it. Some people have this fallacy that code coverage equals quality, and it doesn't. And I think it's even more important for us to think about that in the age where I can get 90% coverage by telling Claude to go get 90% coverage. And what it's going to do is it's going to do branch coverage, right? And branch coverage works in a vacuum, depending on how it does it, how it mocks things. Like all of the challenges that we have with good testing are now multiplied by 5 with AI, because you don't know if the AI is actually producing good tests. Now, over time, if these models get better and they start producing tests the way they should be and they're trained on the right set of code, then yeah, you're probably going to get really great results. But just because you have code coverage doesn't mean that there couldn't be a bug in the interaction, the surface area between those two objects. One of the things we talk about at 7 Factor in the old days was whenever you're doing testing, only mock system boundaries. Like don't mock to the left and the right of your class, because what you're doing is you're eliminating the potential interactions between class A and class B that could produce a bug, because class A could mutate the state in object B in class B that could result in a function call from class A causing an actual bug all the way through the stack. And there's no way for you to know that if you're perfecting the inputs and the outputs of the left and the right of your class, if that makes sense. Sorry, it's maybe a little technical for folks, but the goal and the idea is when you're talking test-driven development, the reason that you write the test first is you're thinking in terms, as Jeremy Wood said, I'm critically thinking about here's the feature I'm trying to produce. Here's the behavior. I'm not thinking here's the code, here's the branches. I'm thinking this is the behavior that I want to produce. And it tends to produce tests that are more durable over time because I'm thinking about the behavior. I'm not thinking about branch coverage. And this is a misnomer, a thing I've run into a lot. And crafts people like Kent Beck and Uncle Bob and other folks that are out there have talked about this idea for a very, very long time, that you need to be thinking in terms of what are the interactions between your various classes. So when you start writing tests in AI, one of the things that I've started doing is asking for full end-to-end tests. I don't just look for testing to the left and the right and mocking and stubbing everything out. I want it to produce for me coverage across the entire code base. The other advantage of test-driven development, and again, I hope AI can replicate this at scale, it'd be great if it could, is that you have less tests that cover more things. Because again, I'm not writing the way we were taught in school, one function per class, right? Or one function per method on a class is what I was taught in school. So say a class has 10 methods, I need 10 tests. And that's in fact not true because of various reasons. You could use a table-based test and get all 10 if you wanted to. Like, there's plenty of reasons you wouldn't do it that way. But the idea, the thought process is what I'm worried, and Jeremy, you're hitting on this. The thought process is what I'm worried about us losing. Is when I'm writing my code, I'm thinking about what I'm trying to produce, not that I'm operating a machine, right? When you're in like a bucket, my son likes excavators a lot. So when you're in an excavator and you're telling the bucket where to go, you're not looking at the levers and saying, well, that lever goes there and that lever goes there. You're looking at the hole in the ditch you're trying to dig. And your reaction and the usage of the controls is what's digging the ditch, but you're still trying to achieve a result. And I feel like when we're raising that next level of programmers up, it's incredibly important that we keep their brains fixated on the result and not on the actions that are required, right? I think that we're going to take all the time I spend in my IDE and my JetBrains and my Visual Studio, type, click, click, clack. We're going to take all of that and condense it into maybe a couple of commands to an agent or a set of agents or a suite of agents, but that should not remove the problem solving that happens in your brain.
Yeah.
And when you get that code, you need to make sure that your worldview and your software systems in your head matches what it's producing, or you're going to vomit garbage into the repo.
So to touch on what Brent was asking about, how do we train junior engineers in the AI way? That's something that we're still coming up with concrete solutions for. So I don't have any of those really. But I will say that I think more than ever, we're going to need people who are good at debugging. And usually
Yes.
debugging is a skill that you get as you become more experienced as an engineer. And if if you're not writing code, like how do you get there? So that's something that I'm still thinking about. But
Yeah.
like that does seem to be a big part of where the humans are going to be involved, like understanding at a fundamental level how these systems work, not
Yeah.
necessarily having to understand the code, but like, again, like I don't know how you get there without first understanding the code. So
Right.
it's a weird paradox almost, of like we need people good at debugging, but maybe not writing code. We'll see.
Maybe.
I
Burv,
think,
Scott, you have anything on that?
yeah,
And
Yeah.
I want to answer Brent's question directly, but I've talked too much. I want to give you guys a chance to talk.
you want to go ahead, Burf?
Yeah. One thing that Seven Factor loves to do is we love to train and educate and learn by pairing or mobbing.
Yeah.
And even before agentic systems came around, that was our primary way to teach. Presenting and doing, lunch and learns and things like that, you can only get so much out of that. Having hands-on keyboard workshops where a senior engineer is training another engineer on how something works or how to build something in the right way is something we've always loved doing. And I think that's more important now than ever with these agentic systems, but it's more mobbing now, where both of the engineers on the call are the navigator and the
Yeah.
agentic AI system is the driver. And you're showing the junior engineers, this is what it produced, and this is why it produced it in this way. And this is how you make it better if you need to.
That's exactly what I
Whether
was
it's
going
with
to
another
say.
prompt or whether it's
Yeah.
with manual changes, that's totally fine. But you can only do those changes and understand what changes need to be made if you can understand the code.
Yeah, I think today pairing is more important than ever. We talked about this on the prep call for this. I truly believe that looking into and experimenting with pairing and mobbing is going to help a lot with this. Why? A couple of reasons. One, when you pair and mob, you're able to solicit more brains on the same code base. Agentic has a tendency, unless you tell it not to do this, although I've not seen it do a good job at this yet, period. Agentic and any form of heavy volume code generation tends to produce a lot of files and a lot of code to review. When I asked Claude to build out this API, this profile service for my microgreens pet project, it did it in little to no time, but it produced an insane amount of code. If I'd written that on my own, the create, read, update, delete, and the IDOR stuff, and all of the specifications, and all of the tests, and all the end-to-end tests around, if I'd done that on my own, it probably would have taken me 2 or 3 days. And again, I'm not making any promises around productivity with AI because we don't truly understand it. You'll read some people on the internet that think, oh, it's this and that. We don't know, right? There's not enough data to say that we know yet. But I do know, anecdotally, in my own experience, that it produced a lot of code for me to review. As a human, cognitive overload, I think, is going to be a problem in the future. So if you've got 2 or 3 developers, so people are like, oh, 2 developers are going to be able to do what teams of 20. God, I don't want to be those developers. I'm telling you now, because I will burn out in little to no time reading swathes and swathes and swathes and swathes of code, at which point there's a lot of duplication. There's a lot of, AI is really bad at looking at existing code base. It's really good at producing something for nothing, but it's not that great at looking at existing code base and producing code that fits in the realm of that. It will duplicate. It will make mistakes several times, or it will rewrite something here and there. And again, the previous argument of should you read code anymore kind of comes to mind. But in my brain, I'm always going to be reading what it's producing because I need to know what this thing is giving me before I'm willing to stamp it and put it out there and let this thing go into production. So I would encourage us all to look at pairing. Look at pairing deeply. It's an experiment that we're running, that we're going to be running much more in the future, both from a consulting perspective. Like the argument against pairing when I'm selling it as a consulting product is, well, I'm paying 2 developers to produce one thing. If I'm paying 2 developers to produce high quality, like buckets of code coming from an agent, I think there's a ROI to be discussed there. And I'm avoiding the burnout of that poor one human who has to read 600 lines of garbage that's coming out of this. And it gets you that training as well, where you've got 2 people working together to produce code, and the expert is able to train the junior on this. To answer Mike's question, we're absolutely hiring junior engineers where we can. We hired a few recently. But the idea is that we're trying to sort is how do we teach them the skills they need to know, because they don't necessarily need to know the semantics anymore of making sure the function's named right. They kind of do, but they kind of don't. You know what I mean?
Yeah, I've heard one take that it's going to be less about how code is written and more about what the code does.
Yes.
Like focusing on someone was saying that like focusing on like learning really complicated language syntax stuff, like that's probably
Yeah.
not something that people need to be focusing on right now.
I also think this is going to change how programming languages are built. We haven't really talked about that because I spent time in school designing programming languages. And I think that a lot of the more esoteric ideas are more difficult to replicate in a model and easier to produce bugs, especially when you look at parallelism. Like we've not even scratched the surface of, go and tell your AI to diagnose and fix a race condition. I don't think anyone, I've not seen anything on the internet. Because what do we build today? We build CRUD dashboards, right? We build create, read, update, delete across a Postgres database. How freaking easy is that? Yes, AI can do that. But if I'm producing scientific compute that has some crazy ass weird parallelism in it with some strange algorithms, can it do that? Probably not, because again, software engineering is what's called a wicked domain. It's like chess. Or no, sorry, chess isn't wicked. It's a wicked domain. It's hard to solve with a non-deterministic model. You have to understand the nuance of it, etc.
There was an example though from a very senior Google engineer who said that they had worked really hard on something. I can't remember what the problem was, but it was something relatively low level and global sync related. It was not an easy problem at all. And they spent like a week to try to figure out what the solution was. And then she went back to her desk and she threw it at AI and she spent a little time to create the prompt to describe it significantly enough. She said in about an hour, it produced a solution that was relatively close to what they had. I mean, was it perfect? No, but it got very close and it moved
Yeah.
forward much more quickly than a bunch of really smart developers could.
So
But see, I think that real quick, I think that that's a problem that we have as developers, period, is analysis paralysis and getting started. It's a thing I've fought my whole career, and even people I've hired have fought with this, where they don't just try something, right? They spend all these days, and again, we all went to school. Those of us who did went to school to learn problem solving, whatever flavor it was, and I just have a problem getting started. And the fact that it can give you something that kind of works is very exciting, because that means now, oh, look, it works. I got that dopamine hit. Now I
Yep.
get my brain going and I can start working on something.
Yes.
So I've heard of this also, Scott, the thing you're talking about, and something that I also found out is that there's a lot of missing context there. So what they didn't tell you in that post was that like one, they've tried all these different things throughout the year, but when they prompted the model, they knew all of that stuff.
Yeah.
And so they knew all the
They
pitfalls
knew
and
the
everything
context.
to
Yeah.
Sure.
like to include in
Oh,
the
absolutely.
context, right? And so like if they
It,
had started fresh with this problem, I don't think that it would have gone the same way.
oh, I think you're absolutely right. And one should not take any absolute conclusions or lessons from any one of these anecdotes because that's all they are is anecdotes. I mean,
Right.
when it comes to anecdotes, I just read about today about a custom programming language that somebody created just for AI. And one of the guys, Simon Willison, had actually written a little fractal uh, computational program in it to see how it went, and it worked out better than he expected it to.
So
Uh,
that's crazy too, to think in
yeah.
terms of maybe compilers or AI one day. Like again, we've only scratched the surface of this and we have to be open-minded. I hate to say it, but it's likely the gone are the days of sitting in front of my IDE and my JetBrains and right click refactor. Like I don't think that's going to be around for much longer.
So I think that's
Just
something that I've been wanting to kind of
it's sad,
jump in
but
and it is sad and it's disappointing, but at the same time, it's an evolution, and it's kind of like when people stop messing with their cars because they could soup them up in their backyard really easily, and now they've got too many computers to do, and now but people actually will hack their Audis and stuff to get them to go
yeah,
faster too. What we're seeing
yeah,
with AI is that there's so many things that they can do that we can encapsulate, and if there's a problem that we run into, I mean, like I'm a huge advocate of TDD, test-driven development, unit tests, absolutely, 100%. But the problem it solves isn't just helping you have quality code or having tests for it. It's to help you think about the process of writing the code and building it. And if you don't
yeah,
need that so much, if you can move past that, then the need for tests, it doesn't go away, it changes. In fact, I think it
right.
increases. But I think when you embrace the idea of solving these problems that we're seeing and running into with AI, and solving them not by saying, well, we have to be careful about doing X, but well, how can we also use AI to solve that problem. For example, the whole concept of orchestration and code review agents that look at certain things, or a security review agent. And nothing's ever going to be perfect, but the more we can think that way, the more we can evolve these agents and our understanding of them. And I think that's where I actually also go back to the junior developers. I want the junior developers to be embracing AI too, because they need to understand how to adapt over the next 5 years as these tools evolve and change quickly too.
Yeah. Go ahead,
So
Jeremy.
just throwing this out there because it feels obligatory at this point, but like the one thing that we have to accept if we're going to use AI tools and solutions, well, so sorry, one thing that we have to be able to accept if we want to use them is the notion that like we have to be okay with it failing sometimes. And so this is like a general advice that I would give for anyone looking to implement AI into their product. Like you have to be okay with something not happening when you want it to. So just as an example that I heard, there was like if you're talking about phone calls, you have people taking phone calls and the software is supposed to like send out a survey after the phone call. You know, if you're making AI in charge of doing that, you have to be okay with the survey potentially not going out.
Right.
Whereas if you build a deterministic system, aka like classically programmed, um, you can guarantee that those phone or that the surveys will go out. And so you have to like before you start using these AI for your product, like make that consideration. Are you okay with this failure? You're talking about a stochastic system. That means it's got randomness. Like maybe this will only happen 1% of the time, but are you okay with that happening 1% of the time? If that's not
Well,
acceptable, you need to be looking at doing this deterministically, aka writing a program that does this, not using AI to solve it.
Well, and that does come down though to the specifications, the need for perfection, right? Because like in certain areas, medical devices, for example, you have to have that, and I agree completely. I think most of the time, though, we don't necessarily, because even in that realm, we run into bugs. I mean, a client I'm working on now had an issue with notifications going out, and they expect all those notifications to go out when a certain thing happens for people to be informed of it, and that broke. It's broken in two different ways, I think, since I've been there, and there's your 1% of the time, and it happened not because of AI, but because of human programmers. So just because you're writing a deterministic system doesn't get you there either. But it's good to keep in mind this all comes down to craftsmanship to me. I remember in the early 2010s, I was, part of a team. We helped kind of create this software craftsmanship manifesto, and the whole concept was to take responsibility for what we build. That we are the engineers, we are the ones who are saying this thing is going to do X, it's going to solve this problem for you. And depending on what you're doing it for, you have to take that responsibility that this is what you are doing. And if you don't own that, you're not really doing that job. You're not really a craftsman. And I saw a quote recently that, when people are asking, are programming jobs going to go away? And it was said that, yeah, software developers are probably going to become a thing of the past very quickly, but software engineering is not. And we are still building systems. We are still building code, but is it the code that we think we're building today, or is it going to be very different? And I'd like to embrace the future. I don't know what it's going to be. I just know it's changing fast.
I think we have to evolve, right? And this isn't just preservation, right? A lot of people on LinkedIn are screaming preservation, right? Developers are losing their first love. And again, I am too, right? I started my life coding HTML on GeoCities when I was 13. If anybody even knows what that is, to sell my magic cards, no less. And so I'm sad, but at the same time, I'm excited because, again, we've just gotten a power tool, right? It's like you get your first hand drill. You're using regular screwdrivers your whole life, and then you get a drill. I did this recently. Yes, I'm old school. I've used a regular screwdriver for most of my life. 2 years ago, I bought a hand drill because they were cheap, and I use it. I'm like, holy crap, I'm an idiot. Why haven't I been freaking using a hand drill for this long? Like, my hands don't hurt, and it screws the things out real fast. So it's a similar idea in that, and I love what you said. Scott, craftsmanship and software engineering is still the key, right? I don't think that we turn it's software engineering has already been commoditized 16 ways to Sunday, right? People have shipped it in the 90s. We shipped it offshore and paid $20 an hour and got what we paid for. These days, there's still a trend around shipping, et cetera, et cetera. And it doesn't matter where you send it. And what I've experienced in the companies we've worked for, the people we've hired in our nearshore crews are amazing because we hold the line on craftsmanship. We say, look, you need to know how to build software. You don't need to know how to write code. I don't care. I care about how you think and how you build software, not that you can write pretty colored words on a screen that have, that solve a math problem. The important thing is thinking through those higher level concerns. So I want to get to some quick questions here. One was from Hera. Hey, Hera. Which AI tools does everyone use, and do you pick different ones for different tasks? I'll answer that, and then we'll get to Josh's question, which is a bit more in depth. For me, Claude Opus is probably the best coding that I've used so far, but I'll let the rest of the team chime in on that because they've used other ones. I use ChatGPT to learn music theory. I freaking love ChatGPT. It's wrong. It's absolute dead ass wrong like 80% of the time. I'll ask it about a product that I know about and it'll make up some stuff. And you're like, you are absolutely high. I'll even tell it you are absolutely out of your mind. And it's like, oh yeah, you're right. And then it'll say the same thing to me. And I'm like, ah. So you have to know, you can't trust this thing, especially ChatGPT. Maybe those models are terrible. I don't know. But I've used it to learn music theory. I've used it to learn lots of great things. I've used it to do product comparison. My wife used it to plan a trip to Hilton Head, and it did a phenomenal job of giving us just a basic set of things to go on. So long as you trust it about 60%, you'll get amazing results out of it. But for coding, I would say Claude. What do you got? What do y'all say?
Yeah, I use the UI based prompting for summaries, for learning, for collecting groups of data that I want to analyze the different options and come up with reasons on my own as well to add to them as to why one thing should be done over another. Like J-Dub said, planning trips, it's really cool for that. But even the non-AI tools like Copilot or IntelliSense, those are still used by me every day as well. I'm not just relying solely on my AI tool and prompting to generate code for me. My IntelliSense can pick up context of things that I've done earlier in the file and finish things for me. So yeah, different tools for different jobs is 100% something that we're trying to identify what's best for what situation.
Yeah, we're all Batman now. You just got to figure out what the right tool is, right?
One of the things that I think is going to be really, really incredible over the next 5 years is how it affects the non-software engineering world. Because we're kind of used to change. We know things are constantly changing, and it's kind of blowing us away. We are arguing about it. We're disagreeing on how to handle it, what to do with it, what it's going to be able to do next year, how quickly it's changing. But Claude or Anthropic, I should say, released a product just I think about a week ago called Claude Cowork, which is effectively like Claude Code, but it's for people who are not technical. And you can point it to certain files on your machine. It does really strong sandboxing in many ways, but you provide it with things and it will go off and it will do things. It will look on the internet, it'll figure things out for you, it'll do research for you, it'll help you organize your tasks, your blog posts, whatever it might be. And so I look at how AI is going to be affecting the rest of the world, and the rest of the world, the lawyers and the doctors, especially, I think where access to volumes of data and pulling it together quickly is going to blow a lot of them out of the water. And I think the whole world's going to be going through a lot of tumult. And we're actually kind of lucky because I think we're on the leading edge of it, but it's going to be a crazy, crazy decade.
So I want to touch on the tools question as well. So Claude Code, well, really, there's a difference. We're talking about AI models and AI tools, and the distinction is important because the models are what the prompts get fed to generate something. But the tooling is the software that decides like how to call the models, how to break down requests, which models to call. So Claude Code will, I think the default is auto mode, and it will decide, well, should it use Opus for this? Should it use Haiku or Sonnet and so on? It'll make decisions like that. And I think that from what I've seen, Claude Code is one of the best options when it comes to agentic coding. But I've recently been playing around with Warp AI as well, which Warp is a fantastic terminal. And they also just have a tool that's kind of like Claude Code built into it. So there's tools like that, but I'm still using AI tools in my IDE as well. There's one, so in JetBrains IDEs, their AI assistant does this really awesome thing. Talk about AI refactoring, like this is the cream of the crop right now. Basically, if you make a change. If you have like a file and there's a bunch of different um, places where you're going to have to make a change based on, it's like, I don't know, you're changing the name of something. What it will do is see the change you made and then suggest the next change in the file. And you can just keep pressing tab and it'll like go through and just make these changes to match what you just did. And it's really awesome. I mean, it's a lot faster than saying, "Hey, Claude, like here's my problem. Here's how I want to refactor this. Do that." You know, like this. Just like I know this change is small. It's going to require changing a lot of places in the file, and it's not a simple copy replace or find
Yeah.
replace, right? Like that's where this excels versus using something like Claude Code. So really, you have to know the tools, figure out which one's right for you, right for the situation you're working on, and that's just going to take experience, really. Like get used to it. Like start working with different tools,
Yeah.
and then to kind of bring this up to Joshua's question about context. That's also something that you have to experiment with. Like, I don't
Hmm.
know that there is a correct way to like organize your repository for AI to be most effective. I think it has a lot more to do with how you're prompting it. Like, what context are you including? Like, if you have a large code base, you're not going to get as much out of your credit, your money, by having it like constantly scan that large code base to find the thing. But like when you're solving a problem, you shouldn't need for it to do that. Like
Yeah.
if it's having to like search through the entire code base to find everything, well, maybe you should have like an index or something that or like a Claude.md or agents.md or whatever describing like the different functionality where it can find these things so that it doesn't have to do these like massive lookups. So I think
Yeah.
there's ways to do that regardless of how the repository is structured. Like you can, I don't think that matters as much as just using the tool correctly.
I think it can. So I want to come in with just maybe a slight difference of opinion there. I agree with you, but I also think that in a scaled world where I have a suite of software systems, say I'm doing microservices because I am, that's the buzzword of the day. Um, uh, and I have 6 different services, but these services interact. They're not pure microservices in the sense that it only does the thing it's supposed to do, like a user profile that only does user profile stuff. Say there's an orchestrator service that calls out to 5 or 6 different ones. That's a spot where I could see AI becoming very confused, and it's difficult because the context window is across X different services, and you have a piece of functionality, an interaction point that hits service A that goes to service B that hits service C that hits service D that hits service X that goes to database Y, and they all come back to some conglomerate thing. And now you need to know 3 different database schemas, and you need to know 6 different service code bases, and you need to know the orchestration code base, and you need to understand the architecture of each of those and how to deploy a fix across every single one of those. Some smart human's going to come up with a way to orchestrate agents such as this isn't a problem, I'm assuming. But is the juice worth the squeeze at that point? So to Josh's point, in those scenarios, a monorepo kind of makes more sense to me because at that point, everything you need is right there. And yeah, if it's a multi-million line monorepo, Claude might choke because that's too big for its context window to understand. But if it's a sufficiently small toy, like maybe under 100,000 lines, I would say you probably get some really good mileage out of a monorepo. Micro front ends are similar. If you can, and we fight about this all the time in software architecture, if I can cleanly and clearly define the single responsibility principle for this particular service or this particular thing, and there are no data dependencies. What I mean by that is I don't have to go anywhere else to do my job. I can do my job right here. I don't have to talk to that service. I can do everything I need right here. Then I would say that's a very simple. I would say that's suited for using something like AI to add features quickly on an existing code base. Same thing with micro front ends. If I am here to only show this one widget and I don't care about anything else, which by the way is very rare in software, having done this for almost 2 decades now, it's very rare to see that. But let's say that you can actually do that. And you build a front end that only cares about what it sees in front of it, then it would make sense for that to be an organizational structure. But then the question comes, where's your ROI on that? Right? How do you scale teams? Like these are questions that everyone hasn't really solved yet. And maybe there's people out there that are claiming they're doing it, but I'm talking about agentic at scale where I have one group of agents solving multiple problems in multiple code bases simultaneously and they are orchestrated. I haven't seen that yet. Could we
Oh,
get there?
you're
Sure.
just missing out.
Oh, am I? Are people doing it? I don't know.
Oh,
I haven't
yeah.
seen anybody do it.
I mean, one of the
That
things I've
sounds
seen
terrible.
recently
How did that work?
is vibe Kanban, where like
Oh.
you basically give Claude or actually vibe Kanban is not for it's for OpenAI, I think.
Hmm.
But
Hmm.
in any case, you give it a Kanban board and it will spin up agents to tackle all the tasks in this Kanban board, move things
Interesting.
over, and so on. And
Okay.
so you can manage agents like that. But
Hmm.
that again, going back to some of the things we said earlier, like, is this going to solve the problem in the right way? I mean, it sounds like using something like that, it's more really vibe coding. Like you're trusting the AI to get it right.
Right.
Because if you're doing it at that scale, like how do you possibly keep up with reviewing everything?
You
And
can't.
well, and if
Cognitively,
you
you can't.
are you actually saving time? Like, is this actually
Yeah.
making you more productive?
Right.
I don't know. I mean, I think that's a big question right now. Like, are these things
Yeah.
truly increasing productivity and like efficiency? I don't
Mm.
know. I think that it's really hard to tell. And
Yeah.
yeah,
I'm skeptical on that too because I don't like there have been lots of studies. I've seen studies that counter studies. It's typical with anything in our industry. People complain and argue over it until, somebody calls somebody a name on the internet, right? It just happens. So I don't know either. I don't. What I can tell you from my anecdotal experience, and this is completely anecdote, and I'm admitting it, is that I was able to produce a decently qualified deliverable in extraordinarily less time on average than I would have if I had done it by hand. Now, that doesn't mean that it's perfect. That doesn't mean that it does everything right. That doesn't mean that it has the best architecture. There's definitely duplicated code. The tests are kind of nasty. And when I asked it to refactor the test, it doesn't do a great job of that. So there's definitely some issues with the technology. But again, do the ends justify the means? I have a working API that is fairly secure, right? And it's doing the thing it should do. So I think that's the question that we have to answer for ourselves as an industry: is at what point does it make sense to just say, yes, this is a tool to use in this case, but how do we make sure that we're not introducing vulnerabilities or introducing issues into the enterprise where I could be hacked because AI is dumb and doesn't produce, secure code? Plenty of big issues there. I want to show you guys something real quick. My buddy John Willis, the John Willis, just posted something. This is kind of funny. Dear CIO, our AI environments are too complex to manage. Said 60% of US IT and business decision makers surveyed they can't operate these projects. It gets too expensive, so they shut them down. So here's the next question that we all need to talk about, and that is the cost of this stuff, right? Because my wife builds data centers. She's a structural engineer. And I'm going to tell you right now, I can't talk about it, but she's not short of business. Her entire company has tripled thanks to this. There's an incredible, immense amount of money being dumped into this. And how are we going to get ROI on that? And the fact that it's just so expensive to run. And I've not really run into this yet. I've not spent any time running AI. Like we're going to get a Claude. We've got a Claude rather thing for the company, but we tend to use our client's Claude or our client's AI tooling just because that makes sense from an IP perspective. I haven't even thought about how expensive this is going to get. So this is another thing that I think people are starting to recognize is you're basically hating a data center with this stuff because these GPUs run freaking hot and
yeah.
they
So
can produce some cool stuff, but good Lord.
and this isn't even like you're talking like economic cost here. We're not even
Yeah,
covering the environmental costs. Like, what is that?
sure. Yeah.
Like, I think about doing something like Vibe Kanban where I'm just like letting these agents run free. I don't know that I can just do that in good conscience with like the
Mm-hmm.
way that these data centers are being built. Like, I've heard
Right.
some things, man, like illegal power generation, like that
Yeah.
just, I don't know.
Yeah, for sure. I think that's something to be concerned about, absolutely, morally and ethically. But taking it back to sort of the cost of the enterprise, at what point do these AI startups recognize that they can't afford their own OpEx? Like that's a big question for me. Like Y Combinator spends a lot of money on these people, on these companies, and most of them are too big to fail and have too much investment that they're not going to fail, and that's fine, whatever. The goal though is as an enterprise, how do I make sure I'm not just burning tokens for nothing? And I'm spending all this money on something that's ineffective. Like again, there's not enough data right now. I'm a scientist. I can't claim that I've seen enough data in either court to say that it's not worth the ROI isn't there. And anecdotally, I'm seeing some good and interesting gains. I'm paying $200 a month for the Claude thing, and it's working fine. It's doing a great job, and I've never run out of tokens. So I think, though, as we move forward and you apply these things to more difficult and more complex tasks, the big question for us as an industry is, at what point does it make sense to optimize this for cost? And I would argue, as a CIO, you need to think about this now. You need to consider what are the toolings that I'm going to use. And this is not even talking about putting it in your product and building your own models. I'm advising a startup that does AI models on this thing right now. Total cost of ownership of model building, running these in NVIDIA's cloud or wherever you can find compute to develop and build your own models to do this sort of classification stuff. And this is a problem before GPU got so fast. Like 10 years ago, I was doing this kind of stuff, and it was already super slow and expensive. Now it's probably 5 or 6 orders of magnitude more fast, which is why LLMs are so useful these days. But the problem still remains in that, how do we develop an ecosystem from a cost analysis perspective as a CIO? How can I justify my costs and align the right pricing models and align the right business value to all this money I'm spending on these GPUs that I'm heating the earth with?
Yeah, and token costs and efficiency is something that drives the decision on what tool you use sometimes too. If a non-tokenized system can get me an answer to the thing that I'm trying to solve or derive an answer from, maybe I use that tool instead. I made a
Yeah.
joke the other day with one of our engineers that as a developer using agentic systems, you're kind of a mini CTO with a budget
Yeah.
and developers or tools under your belt that you can use for any given thing. And your productivity is up to you, and what you produce is up to you within that budget, because we can't just give you unlimited token access to just burn through all of our company's money at any given time, right? So
Mm-hmm.
it's a joke, but it's almost kind of real, right? You're gonna eventually be given a budget of, this is the amount of tokens that you have for this month, or this is a pool that our company has, use it wisely, and then we'll try to find out who we need to help manage prompts and tool usage and things like that. So yeah,
Right. Speaking
this
of
comic is
jokes,
hilarious.
I
I'm
saw this like 15 years ago when
yeah,
I was at Danger, and I was compiling a giant pile of Perl, which was my first exposure to Perl out of school, by the way. I threw up in my mouth, but I figured it out. Sorry guys that love Perl. Um, but I thought it was hilarious then. It was compiling. It was not waiting on the agents to finish. I just posted this to LinkedIn earlier, and I got ChatGPT to generate it. And all I told it was, find me the XKCD about compiling and put agents, waiting for agents to finish. And it did it. It did such a glorious job.
perfect.
But I think, speaking of jokes, this is kind of the joke of the day for me, is literally I was sitting with my marketing team showing them how agents work, and we're just chit chatting while it's just spinning away, and 7 minutes later it produces this giant ass PR that I have to go read. So I think we're in a very interesting place. We have sort of a 3 minute warning. I want to give people a chance to ask any last questions, but I do want to kind of paint the picture of the future from Seven Factors perspective. Number one, I think these are great tools. I think this is the laser chainsaw. I think we do need to learn how to use these things, despite the fact that I've been through the 7 stages of grief with my prior lifetime of writing software. I do think that we're going to have to use these things. I can't predict the future. It could be all the data centers melt tomorrow and we can't do anything anymore. We have to go back to an agrarian society, which place come to my house. I know how to farm, and it's great. But I honestly believe that we need to focus on teaching people. If you don't take anything else away from this, take this. You need to focus on teaching people how to build software, not how to write code, because that's where the change happens. And the people that build software know when to go and look at the code and when it was written, right? They understand the trade-offs of and the issues with taking code that was produced and looking at it. It's kind of like you have a very ambitious junior developer that just vomits a bunch of stuff in front of you, and you're like, okay, I have to go read this. Now, figuring out how to cut that cognitive window is the thing I would love to see people focus on in the industry. If anyone at Google or Anthropic reads this, or whomever, a smart person out there that wants to build a company, I think there's some gains to be won by cutting the cognitive window that's produced by these agents, because everyone's going to have to look at what they produce. I don't believe, and I could be wrong, and if I'm wrong, I'm wrong. I don't believe we'll get to a point to where it's like the right click regenerate, like my previous example, right? If we just hit a button and it produces the executable and we don't even look at it. At least I'm not going to do that. I'm going to look at it because I don't trust it. But at the end, I think we're in a really fun place, and I'm excited about the future with this. But we need to be cautiously optimistic, right? Don't lean into this and go vibe code, a Salesforce replacement, because you're not going to get what you pay for, and it's not going to work at all. Given what I've seen. Yeah, it's not Salesforce. And plus, I mean, remember, everybody on this call has worked in massively complex systems with some pretty deep, algorithms. I've worked in real-time switching systems. I've worked in video transcoding, very, very massive amounts of things. And in AI, the way we build it today probably wouldn't be super useful if we didn't already have the infrastructure that we have with the cloud stuff and all these free tooling and Docker and all these awesome things that we have. So we're kind of at an inflection point in a really cool time in our industry where we need to be very careful. And we need to focus on the right skills, which is not producing code into the repository, but understanding that software is built through a mind. It's built through a set of steps, and it's built by high quality engineering teams that know how this works. Can less people get more done? Absolutely. But there's a cost. We have to understand that cost, analyze that cost, and sort how do we make sure that we're not burning out. And again, pairing. I really think pairing is the answer. Any closing remarks from my panelists? Otherwise, we'll close it up here. Thanks for everybody for joining us.
No, thanks. Thanks for having us.
Yep. Thank you.
Yeah, good talk.
Awesome. Y'all have a good day. We'll talk soon.